Let's remember what it means to square something. Squaring something means multiplying it by itself. So if we have 5 squared, that would be 5 times 5, we would get 25. Same sort of thing if we have negative 5 squared. That would be negative 5 times negative 5, and we get positive 25 again. So when we have this question that says, what are the square roots of 25? There's actually 2 numbers that you could multiply by themselves to get 25, which would be 5 and also negative 5. To indicate square roots that are not negative, we use the radical sign. So the square root of 25, there is positive 5. To indicate if you want the negative square root, you put the negative in front of it. So negative square root of 25 would be negative 5, like so. So when we think of the square root of 49, we're thinking what positive number times itself gives us 49? The answer would be 7. When we think of the square root of 0, well, 0 times 0 is 0, so the answer would be 0. For fractions, it's not as complicated as you might think. You just take the square root of the top and the square root of the bottom part. So for the square root of 9 over 16, the square root of 9 is 3, the square root of 16 is 4. Now, when you've got decimals, I often will use calculators when I'm dealing with square roots of decimals just because they're so tricky, and I tend to make mistakes with decimals when I try to work it out in my head. So the square root of 0.25, if you work that out on the calculator, is going to be 0.5. Now let's take a second and talk about variable powers, like the square root of x to the 10th. Here, the trick is to take the square root of an exponential expression, divide the exponent by 2. 10 divided by 2 is 5, so the square root of x to the 10th is x to the 5th. And a lot of the times in this chapter, we're going to have combinations of numbers and variable expressions. For example, the square root of 36x to the 6th, we want to calculate first the square root of 36, which is 6, and then for the square root of x to the 6th, we divide the exponent by 2, and we have x cubed. Now, I really want to make sure you understand the difference between the next 2 expressions. The first one says negative square root of 4, which would be negative 2. When the negative sign is under the square root like the next one, that one's asking us to find the square root of negative 4. It's saying what positive number multiplied by itself gives us negative 4. And there is no positive number that you can multiply by itself and get negative 4. So here we just have to say not a real number. It's better not to say no solution because technically when you get to more advanced math classes, you'll study what are called complex numbers where you can find the square root of negative 4. Here it's better just to say not a real number whenever you have a negative number under that square root sign. So the next thing I want us to do is to take a look at finding square roots on the calculator. Everybody's calculator is a little bit different in terms of how you evaluate square roots. So make sure you find the square root button on your calculator wherever it is. And for example, suppose we had a problem on the test that asked you to find the square root of 32. Here I calculate that and round it off to a few decimal places here. I get about 5.657. Or if I have the square root of 7, when I calculate that on my calculator, I get about 2.646. Usually I'll ask you to round it out to about 3 decimal places or so. So that's talking about square roots, where you multiply 2 of a number together to see what you get. The next one, we're talking about cube roots. So for example, the cube root of 8, we're thinking what number times itself gives us a positive 8, and the answer would be 2, because 2 times 2 times 2 is 8. Or when we're thinking what's the cube root of negative 8, we're thinking what number times itself gives us negative 8. The answer is negative 2, because negative 2 times negative 2 times negative 2 is a negative 8. Or if we want to find the cube root of 0, well, the cube root of 0 is 0. The root of 0 is always 0, no matter whether it's a square root, cube root, fourth root, anything like that. Same sort of thing with the cube root of negative 1. The root of 1 is always 1. No matter what kind of root you're taking, the root of 1 is always going to be 1. So, for example, the cube root of 1, we get 1. For the cube root of negative 27, at this point, I want to recommend that you take some time to learn how to use your calculator to evaluate roots. Again, everybody's calculator is a little bit different. If you have questions about your individual calculator and how to do it, and you can't find the resources you need on the internet, let me know and I'll try to help you out. But the cube root of 27, because negative 3 times negative 3 times negative 3 is negative 27, we get negative 3. And then just like it was with square roots, for fractions, you just take the cube root of each part. So for the cube root of 1 over 64, we take the cube root of 1, which is 1. And then on the bottom, we take the cube root of 64, which is 4. Remember, we're not doing square roots here. It's not 8. We're doing cube roots. Now, you remember a minute ago, we said that when you're doing square roots of exponential expressions, you divide the exponent by 2. So it makes sense then that when we're doing cube roots of exponential expressions, we would divide the exponent by 3. So for the cube root of x to the 12th, we divide 12 by 3, and we have our answer x to the 4th. Now, if we have the cube root of negative x to the 12th, here's another spot where cube roots are different than square roots. You remember when we were doing square roots of negative numbers, we had to say not a real number, but with cube roots, it's just fine. Cube root of something negative, you just get something negative. So here we would have negative x to the 4th. So if we're working out the cube root of negative 64 x to the 6th, the cube root of negative 64 is negative 4. For the cube root of x to the 6th, we divide the exponent by 3, and we have x raised to the 2nd. So to sort of summarize what we've been talking about here, even roots of positive numbers are positive. Even roots of negative numbers, and by even roots I'm talking about square roots, fourth roots, fifth roots, and so on. Even roots of negative numbers are not real numbers. As we talked about, you can't take the square root of a negative number when you're dealing with the kinds of things we're working on. Then odd roots are different though. Odd roots of positive numbers are positive. Odd roots of negative numbers are negative. So let's look at some expressions with other types of roots now. If we calculate on your calculator the fourth root of 16, again, figure out where to find these roots on your calculator. That'll make this a lot easier. The fourth root of 16 is 2. The next one, the fifth root of negative 32, I know without even thinking it's going to be negative because odd roots of negative numbers are negative. And this one ends up being a negative 2. The fifth root of positive 32 is a positive 2. And then if we're looking at negative square root of 36, when the negative's out front, you put a negative in front of the answer. When there's a negative under an even root, like our next problem, the fourth root of negative 16, we can go ahead and say not a real number. Or if we look at the fourth root of 81x to the 8th, the fourth root of 81 is 3. And as you can kind of guess from our previous examples, to do the fourth root of an exponential expression, you would divide the exponent by 4. So the fourth root of x to the 8th, we do 8 divided by 4, and we would have x squared.